Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to discuss how Grab stores and processes millions of orders every day. Okay, so if you know about company Grab, well and good, but if you don't know, let me tell you that Grab is one of the most dominant apps in Asia offering rides, and now they have expanded broadly their business into food delivery, grocery delivery, package delivery, etc., even in financial service. So today we are going to discuss the architecture of Grab food order delivery platform. Now let us try to understand first how in real world the food order delivery service works. Okay, so suppose here we are having a customer. He or she have ordered some food using Grab app. So first the request goes to the merchant partner. The partner prepared the food, and once the food is prepared, the delivery partner picks up the food from merchant partner and deliver to the customer. Okay, so here I can write delivery partner picks up that food and then they send or deliver that particular food to the customer who have ordered the food. Okay, so this is the simple flow. Now let us try to understand what happens in the backend, how the service works, right? So now before going to the original architecture, let us try to understand what are the things we should keep in mind while architecting this particular system. Okay, so in case of this food order delivery app backend system, both write as well as read event will be coming. So the backend system should be able to handle both of these kind of scenarios. For example, if you consider write events, it can include create an order, then it might have update an order. Coming to the read scenarios, it can have get order by ID. Then for example, it might have get ongoing orders by passenger. Then it might have some historical analysis. Then it might have some statistical analysis, etc., right? And not only that, here if you observe the write and read events, there is some situation where the use case is OLTP use cases and there are some use cases which are OLAP use cases. For example, create order, update order, get order by ID, get ongoing order by passenger. These are coming under OLTP use cases, right? And there are some use cases, for example, historical analysis, statistical analysis. These are coming under OLAP use cases. So the backend system should support both of these. There is OLTP as well as OLAP platform. So now let us try to explore how both of these systems are getting handled by the architecture. And first we will look into the abstract level system design. Okay. So here we are having our Grab order platform. So here customer is making some order using the Grab app and that order platform has those events. So what the order platform is doing, they are ingesting those events into some OLTP storage. Okay. What is this OLTP storage Grab is using? I will come to that, no need to worry. So here this particular OLTP storage can handle all the OLTP use cases, for example, update order, create order, get order by ID or get ongoing order by passenger, etc., And there are some use cases, for example, if business team want to know the historical aggregated result of orders, that kind of statistical analysis if they need for a past few months data, which is obviously is going to be a very big data. So for that we need OLAP system, right? So from the order platform, those events should be flowing to the OLAP system also via some data ingestion pipeline, right? So that way both OLTP and OLAP use cases can be handled, and obviously I hope you can easily understand the system will be eventually consistent. Because in OLTP system, the events will be reaching ASAP, but using the data ingestion pipeline, it will take some time for those events to be available in the OLAP system. Okay, but eventually it will available within few seconds or few minutes delay. So I hope you can easily understand this system is eventually consistent. Now let us try to understand the architecture in depth. Okay, So they have created this architecture using different AWS services. Let me explain you from beginning. So here the customer is making some order which is going to order platform. From the order platform, they are ingesting those events into DynamoDB, which is acting like a OLTP system. There are various reasons behind choosing the source as DynamoDB. For example, DynamoDB is self-managed, that is serverless, and it can scale up based on traffic. Then it has default TTL feature using which very old orders which are 6 months or 7 months older, which are not that much contributing to business, that can be automatically deleted using this TTL feature of DynamoDB. For these kind of reasons, the Grab food delivery platform is using DynamoDB for their OLTP use cases. Okay. And for their OLTP use cases, they are considering MySQL. Now, how the data is flowing from the order delivery platform to our OLTP system, let us try to understand that part. So for this, first what they are doing, they are publishing those events into a Kafka topic. Okay. So here we are having our producer, right? And then the Kafka using consumer is publishing those events in MySQL table. So here I can write consumer. Okay, right? Now obviously they have tried to maintain this Kafka is highly available and fault tolerant, but we cannot avoid the failure situations or hard time when the Kafka is not reachable. But if the Kafka is not reachable, then also the order platform should not be stopping. The business should be keep on running 24/7, right? So that time, if in any case Kafka is not reachable, what this order platform does, using this producer, they publish those events in SQSQ and temporarily store there. And once the Kafka is available from SQSQ, they retry to publish those messages in Kafka. Okay, that way they handle the situation when Kafka is not available by temporarily storing those events in SQS. Suppose due to some reason the SQSQ itself is not available, and obviously that will be very rare situation when Kafka also not available, SQS also not available. That time they are storing those messages in DLQ. Okay. And maybe then they are notifying some admin team or developer team. They are coming and checking what is the issue. And from DLQ, using the consumer, maybe they are ingesting those events in MySQL. Okay. And here I have written two components. One is rewind, one is S3. That is, as you know, when we are using Kafka, there can be some time where we might need to rewind the already consumed messages. For example, if you consider, suppose in this MySQL order table where all the order events are stored, they are up to 2023/06/09, then 13/05/00. That is on 9th of June till 1 PM 5 minutes, the messages got consumed. Okay. But due to some reason, we might need to get the messages from 2023/06/07 3 PM. Okay. That is from 7th June 3 PM onwards, whatever messages are there that we want to reconsume. Now already the consumer has consumed those messages and the consumer is currently running on 9th June at 1 PM 5 minutes. But we need that older event. So that is kind of rewind activity, right? So in Kafka, in topics, by default, the messages get stored for 7 days. Based on retention policy, you can increase or decrease that. So if the messages are stored in Kafka, we can easily rewind by resetting the offset, right? So rewind feature is also possible in this consumer. Not only that, suppose due to some reason, the MySQL database has some issue, the database is down. So obviously the consumer will have some retry here also in publishing those messages. But suppose if after multiple retry also, the consumer is not able to write those messages in MySQL, obviously the consumer can write those messages in S3. Okay. And then what in future can be done? Once the database is up and running again, from S3, using S3 Kafka connector, we can republish those events from S3 to Kafka back, and then consumer can again try. Okay. So it is kind of replay activity. Okay. That is, some events which came to Kafka, but consumer is not able to publish due to database issue. It is publishing in S3. It got the backup. Now, once the database is up and running from S3, we will republish those messages in Kafka, so that the same consumer which was consuming the messages from Kafka, that will consume and try to publish the messages in MySQL. And hopefully this time the messages will be published and written in database successfully, because now the database is up and running. Okay. So rewind, replay, all these kind of activities also the Grab backend system has handled, which is serving the food order delivery data platform. Okay. So I hope up to this you got it. Now here multiple things we discussed already in our previous video, that is for example EC2 Kafka Replay, SQS, DLQ, DynamoDB TTL, etc. All the relevant links I'll be providing in the description box or in the comment section. You can obviously go through that. Okay, right? Now let us try to understand two very important aspects in this particular architecture, what they have handled. Okay, number one is upsert. So let us try to understand why we need upsert in MySQL. Suppose for example, we are having a customer A, who have ordered cake, okay, and order item is 1, right? Now he or she has ordered this particular food using the app. The event came in order delivery platform. When the order delivery platform is trying to publish that event in Kafka, suppose the Kafka is down, the messages went to SQS queue, and by that time what this customer has done, he or she has updated his order, that same cake, the quantity instead of 1, he updated to 2. Okay. So this is another event for the same customer, and that event when he tried to publish from order platform to Kafka, suppose by that time the Kafka is up and running. Okay. So the producer is able to publish this particular update event successfully in Kafka. Now what will happen from Kafka? It will go to MySQL, right? Suppose before the insert event, that is before the actual order, this update scenario arrived in MySQL. So what will happen? If we just only try to update, it will fail because the actual row itself is not there, and we are trying to update the order quantity of the cake to 2 from 1, right? So it will not work. So that's why we have kept upsert, right? So if the row is available, then update it. But suppose if the row itself is not available, then insert it. Okay. So this update event will be inserted if it is reaching to MySQL before the insert event. Okay, right? So before insert, if the update event is coming, the upsert can handle. And there is another situation which is update order execution. So let us try to understand what is that. Okay. So suppose for example, here we are having customer A who have ordered again same thing cake. His order quantity is 1. Okay. This the customer has done on 2023-06-09, that is on 9th June, maybe at 1 PM 5 minutes. Okay, right? And then he or she has updated it, customer A, the quantity he or she has updated to 2 on same day, that is 9th of June at 14 PM. Okay, right? So what happened initially when the customer has made this particular order for the first time from order platform, suppose it went to Kafka and it got returned to MySQL successfully. So in MySQL, what it will be having? It will be having the customer ID, that is customer A, the order name, that is cake, and the order quantity, that is 1. Okay, right? Now he changed the order quantity to 2. Okay. But suddenly he thought, okay, I might need 1 more. So the same customer A only has changed the order quantity for the cake to 3 at 14:05 PM. Okay. So first he made one actual order, and then he has updated the order to 2, and then he has updated the order to 3. Okay. So 2 update, 1 insert. Now the insert activity successfully reached to MySQL. Now suppose this particular update order, that is second time when he is changing the order quantity from 1 to 2, that from order platform while trying to insert the data in Kafka, the producer failed due to some reason. Maybe the Kafka is not reachable, and the producer has published this particular cake to this update to SQS queue. Okay. And when the third event reached to the producer, the Kafka is suppose again up and running. So the producer is successfully publishing that particular event to MySQL, and now here cake 1 is there. So what here happening, that because this particular event arrived to MySQL, so for the customer A, the order cake quantity increased to 3. Okay. So the first insert got handled and this third event got handled. But after the third update got handled, suppose the second update is reaching to MySQL. Okay. So when the second event is coming, what the system will try to do, what the consumer will try to do, it will basically try to update the order quantity to 2. Okay. But this is totally wrong, because in the middle customer made the order quantity to 2, but then he or she has changed his or her mind and then moved to order quantity 3. So order quantity 3, which is available in system, that is latest. Due to system issue, the second update is appearing after the third update or the latest update. Now the latest update is already available in the system. Now this second update, if we try to execute on MySQL, that will be wrong, because order quantity customer don't want to. Customer wanted to one time, but then he or she changed his mind and now his or her latest order is order quantity 3. So what we should make sure that these particular out of order events should not impact this kind of quantity or any other activities in MySQL. So for that, what Grab is doing? Grab is taking the timestamp. Okay. So in the MySQL, not only the customer details, order quantity and order name, along with that they are storing when the event arrived. So for example, customer A has ordered the cake with quantity 1 at 1 PM 5 minutes, right? So they will store that. Let me erase these events. So they will store that here at 13:05 PM the customer has ordered. Okay, right? Now suppose the order update, that is quantity to 3 is coming, right? That is third update what the customer has done. That the customer has done maybe, for example, 14 PM, I guess the customer has done this order quantity change to 3. So before doing this update in MySQL, it will check whether the timestamp is greater than the existing timestamp or not. If the timestamp for this particular event is greater than the existing timestamp, that means this is the latest information. So what the consumer will do? It will update the order quantity from 1 to 3. Okay, right? Now suppose the out of order delivery data is coming. That is customer made the order quantity cake to 2 at 14 PM. Okay. Now what will happen? It will try to see what is the latest information available. The latest information is available for 2 PM 5 minutes. And now this event came for 2 PM. So that means this is not the latest one. So it will simply reject that particular event. Okay. Like that way, based on timestamp, they are doing the upsert. So that way out of order delivery event also gets handled. Right? This is basically overall their data platform flow. Now what my personal opinion is that they could use DynamoDB stream instead of this particular place. Okay, that is here order platform is writing the data in DynamoDB and same order platform has to take the responsibility of writing those events in Kafka. Rather than that, what can be done is like this way. Okay, so the customer has made some order, the event is coming to order platform, then they will write that to DynamoDB or OLTP system. From DynamoDB, using DynamoDB stream, they can trigger the Lambda producer, which will write those events in Kafka, and then from Kafka, using consumer, what they have used earlier, they can write in MySQL system. If due to some reason Kafka is not reachable, the Lambda can write those messages in SQS and have retry after some time. If still it not works, maybe for example, the SQS itself is down, or after certain retry also it is not working, they can publish those messages in DLQ. From there, they can notify the admin team or developer team to inspect. Okay, so they could use DynamoDB stream. That way, publishing same order events in 2 different places and that responsibility is taken care by this particular system can be ignored. Okay, so let me show you this particular implementation little bit. So what I am going to do in this demo now, that I am going to create a DynamoDB table. I am going to create a Lambda producer. And first I am going to launch a Kafka cluster in EC2 instance, and then we will see when in DynamoDB some insert update delete is happening, then automatically the insert update deletes are coming till Kafka with the help of DynamoDB stream. Okay. So for that, what I will do first, I will go to DynamoDB and here I will be creating a table. So the table name I can keep orders. Okay. The partition key I can keep, for example, roll number. In case of Grab use case, you can keep order ID, etc. as partition key. For DynamoDB, it should be number data type. And then here I can create the table. Okay. So here the table got created. Now here what we can do, we can basically create a Kafka cluster in an EC2 instance. And how to launch a Kafka cluster in EC2 instance already I discussed in my previous video. I just quickly will set up that. So I'll go to EC2 instance and launch instance. I can give the name Kafka Cluster, and I can choose Amazon Linux machine. Instance type I can choose T2 micro only. Key pair I can choose one existing one, and then I can launch the instance. So here instance is going to be launched. Till then I will just update the security so that the Kafka broker will be accessible from everywhere. I'll edit the inbound rule. I will make sure all traffic it is allowing. Okay, and let's see. So till now our instance is in pending state. So till then what we'll do, we'll create our Lambda code. So Lambda code is very simple here. What we are doing, that we are importing JSON and all other necessary modules, and we are creating a Kafka topic with name demo testing. Here we are creating the producer because Lambda needs to publish those DynamoDB stream events, for example insert, update, delete, etc. from DynamoDB to Kafka, right? So for that we are creating a producer, right? And here we are iterating in records. If it is remove type events, we are basically taking the old image from the DynamoDB stream, and also we are adding the event type, and we need to add the timestamp also, because just now I have told you that the timestamp for the event plays a very vital role to handle out of order delivery, right? So both in case of delete case or insert or update case, we need to add the creation time for that event, and then we are using producer.send to publish the message in Kafka cluster, okay, which is running in EC2 instance. So I will copy the Lambda code, and then here I will open AWS Management Console in a new tab, and I'll go to Lambda and I will create a Lambda function. Okay, so here I can go to create function, demo, some name I have given, and Python execution environment I'll choose 3.8, create the function. So here I can update the Lambda code and deploy. Okay, obviously we need to provide DynamoDB access to this Lambda so that the DynamoDB stream the Lambda can consume. Not only that, due to some reason if Kafka is not reachable, the messages need to be stored in SQS, right? So we will observe that particular path also. So for that I will give SQS access also to this Lambda. So here I'll go to permission section, and then here I can attach the policy. So DynamoDB full access, along with that we can give SQS full access, add the permissions are added for this Lambda, and then here now we can enable DynamoDB stream for this orders table. Okay, so I'll go to export and streams. From here I can turn on the DynamoDB stream, new and old both image I want to capture. So DynamoDB stream is now on. Now I can go to Lambda, I'll add trigger. So Lambda should be able to publish all the insert, update, delete, whatever happening in our OLTP system, that is DynamoDB, and it should be able to publish to Kafka. So batch size I can keep maybe 1 or 2, that is fine. Starting position, that is fine. Additional setting. So if it fails to write in Kafka due to some reason, if the Lambda fails, then on failure destination should be our SQS queue, right? So I'll just quickly create one SQS queue. Create queue, paste 1, 2, 3, and let's keep all other properties pretty much unchanged and create the queue. So basically this is the queue ARN. So I'll copy that, and retry attempts I can keep 0. Okay, so here you can configure that how many times the retry can be done. Maybe for example, if you are keeping retry attempt 5, then 5 times the Lambda will try to retry publishing those messages in Kafka, and still if it is not able to do, it will publish that event in SQS queue. Okay, so here I can keep as of now 0. Okay, right, and then I will add this. Please correct the error above. Okay, so DynamoDB table here I have not configured. So let me add it now. So here DynamoDB stream is enabled. Retry attempt it is showing -1. Let me edit to 0. So now retry attempt is configured to none. So if the Kafka is not accessible, we should ideally get the DynamoDB stream, that is insert, update, delete, etc. to this SQS queue. Okay, right? So this is pretty much it. Now let's see whether our EC2 is up and running or not, where we can launch Kafka. Yeah, EC2 is running. So I'll copy this public IP, and here I will go to putty and we'll do SSH. So here login as EC2 user. I will change this setting to 10 seconds to avoid timeout issue. And now what I will do, I will follow the instructions what we discussed earlier. Just quickly will execute all these commands to install Kafka and Java. To install Java, because Java is not there by default in EC2. And then we will move to this directory. And then here we will start our zookeeper. And here I will duplicate the session. I will start the broker. So here I will log in as EC2 user. It is logged in. To make sure it is not having any heap issue, I need to execute this particular export command. And then here I can go to this directory. Okay. And I can start the Kafka server. But if you start the Kafka server directly without changing any properties, it will run in private IP of EC2. The Lambda will not able to access. So for that, I will change the advertise listener for the Kafka broker. Okay. So I will use WinSCP for doing this. So I'll go to new site. Hostname I will paste. The user ID I will paste EC2 user. And password I will basically choose the EC2 key pair file. So here I will go to Kafka directory. Within that, here I can go to config, and then here we will see server properties. In server properties, we will be having advertise listener. This advertise listener we need to change to our EC2 public IP. Okay, I will quickly change that. So all these things I discussed in my previous video. You can check the link in the description box. So I can save this now. It will be updating there, and once it is done, we can start our Kafka server. So here you can see it is running in public IP 44.211.166.154, and our EC2 public IP is same. Okay, right? Now here what I will do, I will duplicate the session. I will create a Kafka topic where the order events will be published. Okay. So here what we can do, here we can move to this directory. And then here I will create a topic with the name demo testing 2. Okay, but I need to make sure I am using the EC2 public IP here. And then I will create the topic demo testing 2. So here the topic got successfully created. Now we are ready to get messages in Kafka cluster. All we need to do in the Lambda code, in the Bootstrap server, here also we need to make sure we are providing correct broker URL or Kafka cluster details for our system. Okay, right? So here pretty much this is done. And what I will do, I will start one Kafka consumer also to get the events from Kafka topic. So basically here this particular MySQL part I am not showing because it is almost same what Grab is following and what architecture I am thinking, that is same. So I'm not going to that, like upsert and then update based on timestamp comparison, both will be all same. Only thing what pattern I am thinking that what Grab could do, obviously they might have not done due to some reason, they might have some other consideration like using the DynamoDB stream. So that part only I am showing, that publishing the message up to Kafka. Okay. So here the consumer side, I will not create any consumer to publish the message in MySQL. Rather, I will just start a simple command line consumer. Okay. So here this is the code. So I'll start the consumer. So here currently the consumer is empty because no messages are available in this particular topic, right? So what I will do now, I will publish some messages in our DynamoDB table. Okay. So currently if you see here, if I click on explore table items, here it is empty, right? So we will publish messages using particle editor in this particular DynamoDB table now. Here some insert query, some update query, some delete queries are there. We will execute one by one. But before that, we need to make sure one thing. This particular Lambda, if you see, it is using Kafka producer, which is not by default available in our Lambda execution environment, right? So already we have created a Lambda layer earlier in our previous video for this. So I will just add that particular Lambda layer here. Okay. I'll add this. So it is added. Now what I can do here, our consumer is empty. I will first publish one message, that is one data we are inserting. The attributes here I have kept roll number, price and quantity. Actually it does not matter. I just want to show you from DynamoDB, whenever we are inserting some data or updating or deleting, then the producer is publishing that message in Kafka directly. If you see here how beautifully the quantity, price, roll number, event name, it is an insert event, and when the event got created, that Unix timestamp is coming here. Okay, right? And suppose now I am executing 3 insert. So I'll execute this insert and then this one and then this one. Okay, right? 3 inserts I have made, total 4. So here see total 4 events came. Now here I can execute one update event. Okay, right? So update event also executed. Here you see that event name is coming as modified. That means this item is modified. If in our MySQL system this data is not stored, it will basically insert them. If the data is stored, then it will check that data what is stored in MySQL for that particular row, what is the create time. If the stored create time is greater than this, that means what is stored, that is latest one. The tech stack will ignore this particular modification. But if suppose this particular create time is greater than the stored one, so it will modify then the source data to have the latest information available in our well-loopy system. Okay, right? Now we will observe one delete scenario also. For example, we are deleting from orders table where roll number equal to 3. If I am executing, here it got executed successfully. Then and there here you will see in Kafka also it is available. Event name removes, right? Now let's see, due to some reason if Kafka is down, then what will happen. Okay, so I will just make my Kafka broker down. Okay, so it is shutting down, it is down now. Now what I will do, I will insert one particular record, I will copy that and maybe roll number 40. When I will try to insert, before that here see our SQS queue is basically empty. Okay, now here I will execute this particular insert query. So as per this particular diagram, DynamoDB stream will trigger Lambda. Lambda will try to publish to Kafka. But now the Kafka broker itself is down, right? So what will happen? It will not able to publish this particular event from DynamoDB stream to our Kafka topic. So what will happen? The message will be coming in SQS queue. If I refresh, here it is not showing yet. It should come. So you can check in monitor section. You can click on view logs in CloudWatch. We should see that this particular message publish event will fail. Okay. So here let's go to this and see here it is showing some error in the CloudWatch logs. But it is showing connect attempt to this particular broker failed. So when it failed, obviously it will retry if we have configured retry attempt in the Lambda trigger, but we have not. So directly the message will be going to SQS queue. So let's refresh and see here message is available. If I click on that and if I click on send or receive messages, if I click on poll for messages, here I will see one event is available. Okay, that is basically this particular event. Here from this DynamoDB shard ID, start sequence number, end sequence number, and obviously from the stream ERN, we can get back the event what was missed and what reached to SQS queue. Okay, right? So this is fault tolerant also, because temporarily the events can be stored in SQS, and from there, from this SQS, maybe some sort of consumer can publish those events in MySQL. And obviously using timestamp based approach, out of order delivery also can be handled, right? So I hope you understood this. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.